Hello, good day viewers. In this virtual class, we're going to look at some questions involving logarithm. Here, we're going to typically touch questions that are based in logarithm, specifically change of base. Okay, let's look at the question before us. This is solve for x. If we have a number 1 here, the log 3 base x, or log x base 3 is equals to 2.5. So let's look at this question. Looking at this question, you see that it is impossible for us to apply the law of logarithm because the base are quite different. But a transformation can be done here so that I'll be able to resolve these questions. Now, if you recall, we said that if we have log a to base b, from change of base we can also write this as log a base b, a base c, all over log b base c. But for instance, if we now decide that we are changing the base to a, we now say this is log, the base here is a, we replace a with c with a, also replace with a here. You see that log a will give us 1 over log b to base a. So here we will change this one to base 3. So if that is the case, it simply means that this will become 1 over log x to base 3 from this expression here, plus log x base 3 is equal to this 2.5 can also be written as 5 over 2. Here, having done this, the next thing is that we cannot also apply the law here, because if we do that, you see, if you are saying this times this, you see everything become 1. 1 is not the same thing as 5 over 2. So what we need to do, we can say let this log x base 3 is equal to, let's assume it's p. So this is our question here. So here this becomes 1 over p plus p is equal to 5 over 2. So what we're looking at this is like a fraction, and we need to clear the fraction by multiplying through by the LCM, and the LCM of this fraction is 2p. So if we do that, we're saying 2p times 1 over p plus 2p times p is equal to 2p times 5 over 2. Here p will go with p, and we'll be left with 2. Let me put it here, left with 2 plus 2p times p, that will give us 2p squared is equal to 5p. So let's move 5p to the left hand side. By rearranging, we have a 2p squared minus 5p plus 2 is equal to 0. Equals what? 0. Okay, then this is a quadratic equation. First and foremost, let us see if this equation can be factorized. If it is factorizable, we will understand. We'll multiply this by this, and this will give us 2p squared times 2, that will give us 4p squared. Okay, let's look for all the factors of 4p squared. So we're going to have let's say minus p times 4p times minus 4p, that will give us plus 4p squared. If we multiply it, give us 4p. So minus p minus 4p will give us a minus 5p. So the factors of 4p squared that are needed, to replace this middle term are minus 4 and minus 4p. So we replace the middle term by that 2p squared minus p minus 4p plus 2 equals 0. Okay, then we group them into twos. So the shorty factor here, or the common factor in this bracket, 2p squared minus p, is it's just p. So p here we have 2p minus 1. So the common factor here is minus 2. Here we have 2p minus 1 equals what? 0. So here the common factor here is 2p minus 1. Here we have a p minus 2 is equals to 0. Then if we do that, we can see that either p is equals to 2 or half. But if you recall, we've already said that let log x base 3 is equals to p. So here, let's do a simple transformation here first. This log x base 3 we said is p. So that means we can say s is equals to 3 raised to power p from definition of logarithm. So simply means that s is equals to 3 raised to power p. So now let's look at it. When p is equals to 2, s will become 3 raised to power 2, and s 3 raised to power 2, that is 9. Now let's look at it when p is equals to half. When p is equals to half, therefore x is equals to what? 3 raised to power half. We can say s is equals to the square root of 3. So these are the possible values of x in this equation. Okay, now let me put them here. So s is equals to 9 or root 3. Okay, now let's look at another question. This is solve this. This is another question. Question 2. Said log of x in base 5 is equals to 8 log 5 base x plus 2. So resolve this. Here you see that the bases are different. So we'll look at change of base as well. We'll change this one to log 5 base s2 so that the base will become 5. And like we said the other time, so this will become log x in base 5. Here will become 8 times 1 over log x in base 5. So once you transform this was 1 all over, so this 5 will come here, and here will become the other one, so that the base can become the same. So plus 2. Then if we move further, this becomes log x base 5 is equals to 8 over log x base 5 plus 2. Similarly, we can say let this log be something. Let log 5 base x, let it be d. So here we can also say that from definition, log base 5x or log x to base 5 is equal. So that means our x is equal to 5 raised to power d. So let's just keep this one aside so that once we obtain the value of d, we substitute. Then if we are putting in this our equation, this will become d is equals to 8 over d plus 2. So here this is a fraction. We need to multiply through by the LCM. The LCM is d. So this will become d square is equals to 8. D times 8 over d plus d times 2. So here we have a d square is equals to 8 plus 2d plus what? 2d. So this is a quadratic equation. This become d square. All this term on the right hand side will move to the left hand side. This square, this one become minus 2d or minus 8 is equals to 0. So let's see if this is factorizable as well. Let's look at the factors. Yeah, this is d square times minus 8. That will give us minus 8d square. So let's look all the factors of minus 8d square. We have a minus 8d times d. It will give us this, but if we add it, it's not going to give us minus 2d. So let's try it. Minus 2d. Another factor is minus 2d times times 4d. It will give us this, but if we add it, it's not going to give us minus 2d. But if we change this sign here, this is plus and this is become minus. We say this is minus 4d times 2d. It will give us minus 8d squared, the product. If we add this, minus 4d plus 2d, that will give us a minus 2d. So the appropriate term there is minus 4d plus 2d minus 8 is equals to what? 0. Okay, then we group it in twos. Here we have the common factor here is d. Here we have a d minus 4. Close the bracket. The common factor here is 2 plus 2. Open bracket. I have a d minus 4 is equals to 0. So that d plus 2 bracket d minus 4 is equals to what? Equals 0. Here we can see that d plus 2 is 0, or d minus 4 is equals to 0. So d is equals to minus 2 or plus 4. So like I said the other time, that here once we come here, for us to obtain our x, we said s is equals to what? 5 raised to power d. When d is minus 2, so s become 1 all over 5 square, and that will give us 25. Okay, similarly when d is 4, so it's going to be 5 raised to power 4. So s will give us 5 times 5 is 25. So 25 times 25, that will give us 625. So these are the values of x. So in this video, once you a given equation of this nature and the base are not the same, you can transform one of them so that it can become the other one by just rewriting one as. To make this one look like this, you just say 1 over, you write it in this nature, and the next step is so you let this is equal to another alphabet. So have a nice time. See you in our next virtual class. This all you help me do, subscribe on my YouTube channel, and also share this with on your social media platform.